Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, I'll take you through another new topic that is depreciations. And what you're going to learn first in this main topic is how to find the derivative of a general function. So let's begin. After completing the very lesson today, my dear student, you'll be able to find the derivative of a general polynomial function. This is what I hope you'll be able to do after completing the lesson today. So as usual in your favorite segment of the lesson, Mars is fun. Today I will introduce you to another amazing and very strange concept. That is how you can use mass to determine or to measure beauty of a face. I will explain this concept after completing my lesson today. So stay to the very end of this very lesson. So to begin the lesson, let us first learn the rule. What are the guidelines in order to find the derivative of a general polynomial function? So suppose you have a polynomial function y equals to x raised to the power of n. And this is a function of x. And you want to find its derivative. Derivative simply refers to the result after depreciation. So if we want to find the derivative of this function with respect to x, because it is a function of x, this simply means dy by dx. This is the meaning of the derivative. That is derivative of this function y with respect to x. And this is nothing but d by dx of the function. Look at the function. Instead, y I have replaced it by this bracket. Inside the bracket is x raised to the power of n. Because here y is nothing but x raised to the power of n. So derivative of y is now derivative of x raised to the power of n. So I put it d by dx of x raised to the power of n. And what the rule tells you to do if we had to find the derivative of this. So simply this power n will now come and be the coefficient, and the power n will now reduced by 1. So derivative of x raised to the power of n with respect to x is nothing but n times x raised to the power of n minus 1. So what you just notice in this very rule here, the power will now becomes a coefficient and it will multiply that very term. And that very term, the power will now reduced by 1. We are going to take examples how we can make use of this very simple rule to find a derivative of a general polynomial function. So let's just move. Example number 1, it says find the derivative of y equals to x raised to the power of 5 with respect to x. So this is the function that we are to ask to find its derivative. It is the function y equals to x raised to the power of 5. Solution to this very problem. What do we now do? First is to find the derivative of this. So this is the function y, and that y is x raised to the power of 5. So we now have d by dy by dx, that is derivative of the function y with respect to x. This will be nothing but d by dx of x raised to the power of 5. I have replaced this y by x to the power of 5 because the function y equals to x raised to the power of 5, meaning y equals to x raised to the power of 5. So we now remember the rule that we have just learned. We said this power will now become the coefficient and the power will now reduced by 1. So there I'm going to have 5 times x raised to the power of 5 minus 4. Look at it. And the power of 5 will reduced by 1. And that 5 now becomes the coefficient. Here, if there is another coefficient, it will multiply it. So subtracting 1 from 5 gives answer 4. So the end result will now be 5 raised to the power of x, 5x raised to the power of 4. This is now the derivative of this function y equals to x raised to the power of 5. Let's take another example. Example number 2 is says find y prime. Y prime simply means the derivative of y, and it is the same as dy by dx. If what happened, the function y is x raised to the power of minus 7, and this function is a function of x, so we have to find the derivative of this function with respect to x. Solution to this very problem. So y prime is nothing but dy by dx, like I have said. And this will be nothing but d by dx of x raised to the power of minus 7. I have replaced y in this dy by dx by x raised to the power of minus 7. So you now remember the rule. The rule says that the power will reduced by 1, and that power also, before you reduce it, it will now becomes it will now multiply whatever the coefficient you have there. So this is now equals to minus 7. Look at it. That power minus 7, x raised to the power of minus 7 minus 1, like I have said, the power will reduce by 1. So you further subtract 1 from this minus 7. And subtracting 1 from minus 7 gives you minus 8. So the final result is now going to be minus 7x raised to the power of minus 8. This is the derivative of this very function, that is dy prime. Let's just take one more example. Example number 3 says find the dy by dx if you have the function y equals to x raised to the power of 3 over 2. The 3 over 2 is the power of x. Solution to this very problem. So dy by dx of this very function is the center as you replaced y by this x raised to the power of 3 over 2. So you now have d by dx of x raised to the power of 3 over 2. So we continue. So what you do next is now to use the rule there we have just learned. It says the power reduced by 1. And that power also will now multiply whatever coefficient is there. So you're now going to have 3 over 2 x raised to the power of 3 over 2 minus 1. I'm trying to remove 1 from this power 3 over 2. So subtracting 1 from 3 over 2, remember 3 over 2 is just like 1.5. So there, subtracting 1 from 1.5, it will give you half. So you now have 3 over 2 x raised to the power of 1 over 2. This is the derivative of this very function y equals to x raised to the power of 3 over 2. With these few examples, I'll stop in this very lesson. I hope you'll be able to find the derivative of polynomial functions. Let me just move to the last segment, maths is fun, and explain that the concept of using maths to determine beauty. So this is maths in beauty. That is how you can use maths to measure beauty. This is an interesting concept. It says to many people, beauty is subjective. That is what you consider the face or the person that you consider to be beautiful may not be the same case with me. Similarly, the person I consider to be very beautiful may not be the same with you. This is what we mean beauty is subjective. But according to the ancient Greeks, they think differently. They think that beauty, there must be a standard of measuring beauty and rating people in terms of the level of their beauty. So this is according to the ancient Greeks. They think that this may not be the case. There must be a standard of measuring beauty. And what they discover, that they discover most beautiful faces have their facial ratios very close to this value, 1.618. And this value is what we popularly know as the golden ratio. So most beautiful people, when considered their face ratios, that is the length of the face compared to the width of the face, and so many other facial ratios, which I'll take you through in my next lesson. So discover that those ratios are now very, very close to 1.618. This is the golden ratio. Let me just give you a typical example according to the ancient Greeks. It says the facial ratings of this person, Bella Hadid, which is considered the most beautiful person in the world among some world celebrities. This is what they used, this is what was discovered from her face. These are the ratings of her face, all these percentages that you're going to see, or that you can see here, are computed after measuring some of these facial ratios. And they discovered that these are the percentages. The percentages simply how close those ratios are to this value 1.618. Let's take example 97% close to 1.618 is her forehead. 88% close to 1.618 is the eyebrow. Look at it. This is 93.4%, close to 1.61. It is the ratio of the nose. Similarly, 95.8%, close to 1.61. It is the position of the mouse. And 94.1%, close to this value, is the lips. Similarly, you can see her high rating, 99.7%. This is her chin, close to 1.61. These percentages are just computed based on some measurements and some calculations that discovered these are the percentage of this body or of these face parts compared to this 1.618. So according to the ancient Greeks, those ratios of the face, how close are they to this value, is what determines these percentages, and it what determines overall measurement of the beauty of that very person. I'll take you through in my next lesson, and the segment marks is fun, how we can determine or how we can now measure those ratios. Thank you for your attention. We see more of this in our next lesson.